Thank you. All right. So I guess Annie introduced me and I introduced HANGZHOU, but let's do a quick round of introductions. And so introduce yourself and kind of tell us what is the key topic which keeps you up at night? What is your most important kind of topic you think about in as it relates to this panel or in AI and open source, anything?
Okay, so please allow me to start from English, okay? I'm Minghui Zhou. I'm a professor on computer science at Peking University. So basically, I and my students collect and analyze open data to understand how open source ecosystem works and try create techniques to help control the large, complex system and the ecosystem. At the same time, I'm actively engaging in lots of initiatives, open source initiatives in China involving open source education, open data, open source tools and techniques. Okay, thank you. That will be my brief introduction.
Thank you very much. Walid?
Hello. First of all, I want to say how much a pleasure it is to be here, and it's such an honor to be in such a beautiful place. And I wanted to extend my thanks, my gratitude to the organizers. Thank you for having us. It's been so great to be here. So I'm Walid. I'm the head of the Future Networks division within ITU, the development sector. ITU is a technical UN agency. It's one of the oldest UN agencies out there. We just celebrated our 160th anniversary this year. So in our day-to-day kind of mandate or duties, we try to assist member states and administrations in their digital transformation and supporting administrations in understanding new technologies and what's the best way to adopt them for socio-economical development, so a particular focus on the developing countries. And we're based out of Geneva, Switzerland.
Thank you very much, Walid. Xinwei?
Hi, the name is Xinwei Hu. I'm currently the chair of the Open Oil Technical Committee. I've been act as the chair for about 6 years and running the technical committee and also lead the all the technical activities in the community. So what I want to share is that by the 6 years of experience, I think one of the most important things is we need to help the technology actually deployed in the real scenarios and be used by the real user and get some feedback from them. And that's the only way that actually make technology helpful to the economy, to the society. And so open source is one of the very good ways to do that. You can, by open sourcing the code to cultivate the talents and to lower the technical barriers and also to lower the owner of the cost of the piece of the software. And I'm quite proud of that Open Oil has been one of the rapid growing community, and also we want to contribute to the prosperity of AI in the future as well. So, thank you. And by the way, I'm kind of local, so you're very welcome to be here in Zhejiang.
Yeah, thank you very much. And we've seen, of course, your presentation at Show and Tell, who was here before. So thank you for that. And Johan obviously gave us a talk right now, but please kind of introduce yourself just for the completeness.
Yeah, so I think, I don't want to do my self-introduction already, but for me, the most important open source project, actually, just as I mentioned, that is the Flat OS for open compute. And I'm very glad that this year, actually, part of the project has been accepted by the PyTorch Foundation as the ecosystem project. Yeah, so we hope that can enable more global collaboration.
This is great. So I have several questions, and I've sent them to you, and I noticed some people remember them, some don't, so I don't want to kind of follow the script. I want to, and I heard the previous panel, so I kind of whittled it down to a few questions. But before we delve into kind of specific science, open source, and AI, I wanted to ask you a question kind of, as humans, can you share a personal experience, either in open source, in AI, in science, anything, which kind of can illustrate what motivates you, right? So I can give you an example for myself, and maybe you can follow in anything from your life. So I came to, the Bay Area to join a startup, and I had a PhD in computer science. I was the first graduate student who received live data stream from Twitter. So my claim to fame is I discovered Justin Bieber. Nobody knew who Justin Bieber was because he was, like a 12-year-old kid. So I built influence metrics on Twitter. And so when I came to the Silicon Valley, I was in a startup which used Ruby, which is very kind of slow. And then I decided that I want to do it in Scala, which is the language in which Twitter was written. And there was no meetup in Scala. All of them are dead. So I started a new one called Scala for Startups. From about 30 people, I grew it to the biggest Scala meetup in the world, right? And if you know a little thing called Spark, at that point was a toy project at Berkeley. It was actually a toy that was a test example for a system called Messes. So Matei Zakaria was a graduate student. I invited him to present it at our meetup, and we did the very first Spark meetup. And now Databricks is a $100 billion company built almost entirely on the open source community engagement, right? So I think this is an example. And then I met Jay Krebs when he was at LinkedIn. He built a system called Kafka. Very few people knew about it. I invited him to speak at our meetup. And again, Kafka. So come to speak at my meetup, and your company will be a multi-billion-dollar company. That's kind of a little heuristic, but it's a joke. But really, kind of for me, I experienced this power of the community. I wanted to learn. I wanted to invite smart people. Tell me, right, what are you doing? And I found that this is actually important for others as well, right? So my kind of passion for community translated into these meetups, and then I created a conference, and then I essentially was leading communities at several companies, including Neo4j at this point, and AI Alliance, right? So I just wonder, like, if you had an experience which made you a scientist, a teacher, a leader of industry, like, tell us anything kind of where you came to kind of do what you're doing right now.
Okay, I think I'll start, okay? Okay, I am a researcher, as I said, collect and analyze data, massive open data, to understand how open source project, how open source ecosystem works, okay? That's the thing I'm really interested in, okay? So allow me to come to my stories. I think almost 2 decades ago, I analyzed 2 open source software projects, Mozilla and Loam. Okay, at that time, I did an interview with volunteers in the 2 open source communities. Okay, I remember very clearly one contributor to Loam responded, and he said, I am working in Africa, anyway, some country, as a volunteer. And I described all sorts of details, how he looked at the benefits of open source software to the human species, and why he did what he did, and how he split his time working for open source projects and working for poor people in Africa. I mean, yeah, I'm very impressed by the volunteers in open source software. Yeah, that's one story. I'm very impressed. Another story is at that time, I was investigating the open source software project, trying to understand how developers grow their expertise over time. What impressed me is I changed the data one by one project, and year by year, the principle shows itself. Is my point clear?
Yes.
So I'm impressed by the principles, beliefs, the data that demonstrate the relationship between developers and artifacts. So I think I can discover the principles in the data about how people develop software and create the ecosystem.
Thank you very much. So you're a true scientist studying computer scientists and developers, which is exactly on topic of this panel. So thank you very much for this. I appreciate it. Walid.
Yeah, for me, it's more of a personal journey sharing. It's not as flashy as Spark and Kafka. Those are really impressive. You know, growing up as a student, I mean, I grew up in a pre-internet era. I mean, time flies by. Right now, it's like really not relevant. But access to information as a student was extremely hard. We had like, you know, paper version of the classes shared by our professors, and that was like the only thing that we can get our hands on. So we grew, like growing up thirsty about discovering science, etc. I think the aha moment was like at a certain point in my engineering school. We had like a Nobel Prize, a French professor visiting us and talking about like photons and communication, etc. And it gave me like some sort of a direction, but I was struggling to really find a path and being able to access any information or you know, any material. And that was kind of the drive for my whole career. So I ended up like finding a way how to finish a PhD in photonics and then follow up with that on a career with Google. But I realized it was kind of like a one-off journey, and I wanted, like, once I ended up in Silicon Valley working for Google, I kind of realized like I needed to kind of share more, even if within this internet era, it's really yet hard to find a path and be able to access the information. And as I went on joining ITU, which is, by the way, responsible for the standard for the lasers communicating and empowering all the communication for the undersea cable, it felt like we needed to give more back to developing countries and help bring a critical number, a critical volume of developers and of scientists that are able to tackle our world problems. Today, we face global challenges, not only at the local level, but like climate change, things like that. You might agree or not, but these are like global challenges that require really many people from different culture and from different perspective tackling those challenges to give humanity a chance to be able to succeed and come through these things. So I'm a firm believer in a fair access and fair opportunity and for everybody to come together and try to tackle these challenges. So that's kind of like the journey, and I think the UN is a particular place to come up. It's not the perfect place, but it's the best what we have. So that's how I look into it, and that's kind of the personal take I have on it.
Thank you very much. This is the path from Africa to global community, right? Thank you so much for that. Shinwei.
Oh, it reminds me that back to the university time when I just started to learning operating system. At that time, my advisors and my friends all believe that FreeBSD, I'm not sure how many of you still remember that name, is far more superior than Linux. And I also spent years working on FreeBSD, mostly the network stack. But years after years, I just figured out that Linux is more popular. It's not because it has technology advantage, but also because it has more users, more real users, and the community is more thrive and more. Both more users and also more developers want to put their effort into the community and make Linux, both the kernel and also the user space, more like improve it iteration by iteration. And this gave me the thought that we see a lot of open source projects in China, and some I think are also pretty good. But if these technologies is not being deployed and used by the real user, and you don't get feedback, you don't get the joint effort from other developers, it won't go very far away. And I think this is a very good lesson for me in my about 20 years working experience in my career. That's why when I started to work on OpenEuler, I think one of the most important things we want to push forward, we want an open community. We want as many as developers can be joining in the community, and also we want our work can be deployed in the real scenarios and get direct feedback. And yeah, I think that actually one of the reasons helped me to push the community forward. And also I think there's very good the ideas, I think, from Professor Wang Huaiming, and I believe Minghui also contribute to that. He has the idea that when we talk about both open source and software engineering, both paradigms is not enough. So the traditional or the legacy software paradigm is good for delivers the certain or the deterministic requirements, but it's not very flexible to the dynamic, keep changing requirements. It's not good for innovation. And on the other hand, if you just look into the open source community, you see a lot of projects will fail, partly because that nobody actually use it. And I still remember they have the number that if you count in source code, you can see that about 60% or more never been downloaded. So you can just work on your pet project, but nobody care. And they raise the idea that we actually need is called the crowd intelligence paradigm to combine the good part from both the software engineering and also the open source paradigm to make your project both very can support the keep innovation and while maintaining the quality and focus on the real need by the user. And I think this is also one of the things we want to we want to practice in OpenEuler as well. Yeah.
Thank you very much. So now actually I have more insight on OpenEuler because from FreeBSD to Euler, the community is a strength, right? Like you really want this kind of closely knit community which FreeBSD have replicated, right? This is great insight. Thank you very much. Yanghua.
Okay, yeah, I want to share the story about the open source journey has changed a lot. It can be divided into 3 stages from my personal experience. The first one is around 18 years ago. Actually, at that time, my background is a lot in the system architecture. So I work a lot on different kinds of chipset. So around 18 years ago, at that time, it is the multi-core processor just come out. IBM, Intel have the multi-core processor come out. And at that time, we want to try the communication library, the mobile communication, like the WiMAX, LTE, because the base station to support this WiMAX or LTE, they have a heavy computation on the DSP or FPGA. So at that time, we want to run the stack and optimize them onto the new multi-core processor. That is called the software-defined radio, okay. But we just want to optimize those implementation onto signal processing or network protocol onto the multi-core processor. We look for any kinds of open source implementation of WiMAX and LTE, but we don't find any piece of code in the open source at that time. So to prove our idea of the optimization, our team had to spend almost 3 years to implement the WiMAX and LTE physical layer and MAC layer from scratch because there's no any open source code at that time. So really spend a lot of time just to prove that. So I just imagine that if the open source implementation at that time, because you can imagine at that time, all the equipment manufacturer or those, a lot of company in this area, they have all have their own implementation to support the same protocol for 3GPP. So, but there's no one open source that. So again, we have to repeat all this work for 3 years. So I think that's the first stage. And the second stage is in 2000, around the 14 or 15. At that time, the GPU and FPGA, people want to use that to accelerate the workload in data center and even accelerate the workload for deep learning. So at that time, we want to try how to virtualize and manage this accelerator in the cloud. And lucky for us at that time, because OpenStack. So because we have OpenStack at that time, because at that time, those big companies, they drive the OpenStack open source, including the, I remember at that time, Intel, IBM, a lot of big companies, okay? And including Huawei at that time. So it's easy for us to implement the virtualization for this accelerator and link them into the, for example, the NOVA and other components in OpenStack. And now we can see that it's not only those big companies to drive the innovation. I mean, in AI, especially currently in large model. This morning, I still remember CSDN say currently already have more than 400 million open source projects on GitHub. So I believe a lot of individuals, they already can open source their own project on GitHub. So I can see, let's see, around 20 years ago, no one open source those common things. And around in 10 years ago, it's the big company, they drive the open source, like the OpenStack, those big projects, very successful to contribute to make today's cloud industry. And today, not only those big companies, but also even individual developer, we can do the open source. And I can see that it really speeds up the innovation cycle and really important for open science. Yeah, thank you.
Thank you very much. So from chips to software, basically the foundation, right, which is necessary to enable all the compute for all open source, right? And you use open source to make that easier. So that's a great story. So, I kind of asked this with an idea to give us all kind of a context, because the topic of this panel is very broad, right? We're not going to solve any kind of deeply kind of entrenched problems, but I think we can highlight some of them. So science, open science, it's already a problem because science is silent. Silence is even, there is proprietary kind of problems in science. Scientists actually are very focused on their scientific discovery, right? So, like you work with scientists, your university and, BAI, and we've seen this amazing presentation in the keynote, and I think it kind of highlights both challenges and opportunities that a lot of science is very fragmented. Science is funded by national institutions, right? Scientific incentives are fragmented. So I started this project called Open Source Science at IBM Research. When I joined IBM Research, it did not have a strategy in open source. So I proposed open source science as a strategy for IBM. And so we partnered with NumFocus, which is the nonprofit for Python data stack. And so for 3 years, we basically worked with scientists and open source developers. And so what I personally found is that, first of all, it's extremely hard. It's much easier to be in industry. In industry, you can get a lot of money and solve a lot of problems. In science, it's not enough because the funding comes, right, not from VCs. You cannot drop $100 billion on science. It will not solve anything because the money is distributed by national funding agencies. There is kind of whole hierarchies how it's getting done, who approves what is important, right? So the nations and agencies like in the EU, right, there is kind of cross-EU funding. So in the US, it's a different story. There is, NSF and NIH, and there is all of this is in flux. So scientific funding is actually different from industry funding. And so if you come from open source, if you're a developer, you're used to solve problems quickly, and you're used to solve things on merit. You can be a penguin at the computer, nobody cares. If you solve problems, you will be the most respected penguin in the world, right? In science, you have to be approved by a whole variety of bodies, right? Your papers should be respected in the community. So science is like a church. You have to bow to the leaders of the church. In open source, it's complete meritocracy, right? You can do whatever. If you have most stars on GitHub, you win. So we have clash of cultures, but as we know, open source always wins. Right, open source wins every time. The question is, if science is using open source, and now especially AI, and AI can change any kind of science. So my question to you, how do you experience, and like you're all senior leaders, you've seen how this works in different contexts. How do you envision how science can be disrupted by open source if there are different cultures here, also different national cultures? So we all come from different regions, we come from different cultures. So I wonder, how do you think can open source can help science, and science solves, obviously, a lot of problems for humanity. Like we've seen, vision, right? We all have the same anatomy. We come from different cultures, Russian, Chinese, Japanese, Americans. If BI solves the modeling of neural paths which can help us, help vision, it will help all the people in the world. The promise is enormous. So, if Yohua builds the compute foundation, which helps BI solve this, and then the whole humanity will win. However, right, science is fragmented, there is competition between nations. So how do you see science and open source interacting? What are the problems and what are opportunities? What can we do to help science use more open source?
Okay, sorry, Alex, I have a question for you.
Yes.
Okay, people say I like to debate.
Yes.
Okay, so.
Debate is great.
Yeah, the question for you is, you said open source or developers and the scientists are different to deal with, right?
Yes, yes.
Because open source, you talk to Huawei, if that interests Huawei, the people will do it, accomplish it right away.
Yes.
But that's not how scientific community works.
Correct.
So could you give me an example? What do you want to achieve in the scientific community, but you failed?
I can give example from what I've done at IBM. So we had the unit called Accelerated Discovery. And so the team is based in Zurich. IBM has a lot of expertise in material science, right? So, and the idea was, let's use AI. Actually, we started using large models for chemistry before ChatGPT came on board. So that was, and then I'm a computer scientist. So I think, I can talk to chemists. How hard can it be? I'll understand what they're talking about. So what I found is, chemistry is just like, if somebody is in the audience, is there any chemists here? Can we talk freely about chemists? Okay, I hope I'm not offending anyone, right? But what I found, again, personal example, chemistry is extremely divided. So somebody says, I work with small molecules, somebody works with big molecules. It's hard for them to communicate with each other. They do not think in terms of, and so then, they will come to IBM and they want to raise grants with IBM. And so one lab says, let's make this grants so we can do this, kind of X-ray. Let's analyze we synthesize the molecule. Let's understand what it looks like now. The other said, let's model a molecule. Let's create a molecule. These two groups of chemists will not talk to each other. They have no idea how to exchange big data pipelines, how to kind of write petabytes of vision kind of data. So they don't know about this because they're not incentivized. They're not computer scientists. They're not studying it in school, so they're very silent. Somebody working in one area of chemistry does not know how to produce data, exchange it with other people in chemistry. If you talk to their labs, they don't know about it, they don't know how to get money for it. So in my mind, if it's the part of a big company, they probably would talk to each other, find how to fund each other, how to pass data to each other. But in different labs, in different universities, it's just not set up for this. Data interchange is not there. Data thinking is not there. Again.
Okay, I got your point. My point is scientific discoveries come before the real software. That's one. If scientists discover something, they may become something that can help the industry.
That's right.
But not everything. But we need to have discoveries first. Okay, that's one. Yes. Second, different scientists have a different nature. Yeah, some people may not be good at something you complained about. Okay, in simple, I'm just a defense scientist as a scientist. Okay, done. Okay, so please let me answer your question. This is the AI era. Okay, so scientific science is disrupted by AI. So for example, as AlphaFolding, in the past, it takes 1, even 2 years to discover something. But for AlphaFold, it discovered in 1 second, okay, in that sense. So I think in the past 5 years, the scientific community seized to make innovation to some extent, and all the communities, as you observed, are very isolated from each other. I mean, every discipline is developing by its own. So many branches, but they are isolated with each other. So I think AI really provided a question for the academia. What I do in the past is replaced by AI. So what should I do in the future? Of course, that's not me, because I study people.
Yes.
People live change.
Yes.
I'm not going to replace by AI. Okay, that's other. Okay, so my point is the researchers started to ask themselves, what should I research in the future? Because what I do in the past has already been replaced by AI. At the same time, AI really offered opportunities for people to look the future.
Yes.
So due to the time limitation, I'm going to handle, yeah.
Yes, if I may quickly react to a couple of
Please.
things here. There are things that they do touch me personally. I think, first of all, just kidding, man. Like maybe you should switch seats and have Dr. Zhu be the moderator, but 'cause now she's asking the questions. But there are things I need to react to. I mean, here in that analogy about researcher and church, it's actually exactly the opposite of that. And I could refer back to Galileo when he came to church and pur si mueve, I mean, and yet it moves. That's the opposite of church. That gives you like really what research should be about, as opposed to like, you know, and I don't really share the thought of like the scientific community not being open or not sharing. There's always more to do, but like the scientific community shares between like in conferences, etc. There's more to do in this new era, but there is a very, I think, popular debate that was on the net between Elon Musk and Yann LeCun, who's a French AI lead at Meta, and the discussion was about like engineering versus research, and Musk was saying like, we don't need researchers, engineers can do everything. And I tend to agree with LeCun answer to that, which is like, you need researchers because the time horizon to which you're looking at things are completely different. Engineers look maybe in a quarterly base or like in a couple of years time horizon. We need researchers, we need that thinking of like longer time horizons, like over tens of years, decades. And for that, you need researchers and you need to fund that. And we're actually lacking funding for that. It's not all the national kind of institutional funding for research is showing its limits, and we need to have more private sector funding for globally in university research. Now, back to the subject here of open science and open source. Open source is the foundation. It's really important to have open source and open data sharing, particularly when we have scientific publications. However, research and scientific publications are in a different perspective and a different lens, because you need to assure quality. You have quality insurance. So that's why there's the peer review mechanism. It takes time. It is slow. It can be better. It can be improved. But that's what the best that we have today, and that's has been proven across time to like produce the best results for scientific discovery and science research. So, yeah, there are things to improve, but we need both. We need both.
Absolutely.
Yeah. I'll stop there.
I'm just playing devil's advocate. I know the scientists are open, but I think the software engineers are more open right now, right? Like the open source culture is more global. At least that I would.
Different scales, different. Yeah, we're not comparing apples to apples.
I wonder what Shinwei thinks, right? So open earlier, like you want to build an OS for the future, right? It will be like end to end for all the people. So what do you think? Kind of, how do you see scientists kind of getting onto it?
Yeah, you mentioned that you think science is like build a church, and it reminds me it's a debate about the Cassandra and the Bizarre. It's about open source, right? And my personally is spend most of my time in the technology. So I used to think scientific things is like solid, rock solid, and 1 is 1, 2 is 2. But after I read the book, The Causal Theory from Paul Julie, and I realized that most of things that don't have the very clear cause and result, don't have the very clear link. So science itself is debatable in a lot of areas. And so in that perspective, I think one of the important things that open source can help science is that make the diversity, and so that's the reason I really love archive. There's a lot of papers is preprint, so it's not fully reviewed. There's a lot of voice, right or wrong, but it can be like this is there. It's debatable, and you have a lot of resource to make your own judgment. And I think that's something. Open source can help the progress of science in a way.
Thank you. And Yanhua, so you understand, you're kind of chief engineer at BAI, right? So there should be scientists of all kinds who need compute and who need models. So you probably see different examples. What do you think of kind of, can scientists kind of, can open source and AI, open source AI help all scientists, and how can we like generalize, right, AI to all this? Because everybody, for instance, biologists think that the AI is very special because they're very special chemists, but AI can be very general, right? And like they think, you don't understand my problem, I'm very special, but if you're an AI person, you say, sure, I can understand it, just drop everything in a giant AI system, it's gonna learn whatever it is you're doing, and it's gonna probably do it better. But scientists resent this. They're like, I have special skills, you cannot replace me. I spent my whole life for this, right? How dare you bring this AI to replace me? What do you think?
Okay, yeah. Sorry, I don't want to comment if the current AI's model is better than science or some special science skill, but something special there is the data. Because a lot of scientists, scientific area, we do need the experiment data, okay? And in a very long time, the experiment data in universities or in the research lab is not encouraged to open source. So you can imagine that if there's no experimental data, even for the strongest AI model, people cannot benefit, okay? So, but currently has some kinds of change. You know, one more thing is if you compare why those science in the scientific area or the academic area, people have less open source data there because of the citation. You know, currently, if we have in a long history, I have a public article, people do the citation for me, and then the Google index, those kind of index, I can get the higher rank, okay? But people, in a long time, people didn't do the citation for the data set. So that's why there's no motivation for scientists. They do the experiment and open source and open the data set. Okay, they just publish the article, but didn't share the data set. Okay, but currently in the government, for example, in China government regarded this as a very important issue now. So they encourage the universities and academic research in China to open source the data set of from their experiment. For example, we create the index, data index system for the scientific data set. Yeah, you can choose, I forgot the name of the URL. It is some place in some academic public website, okay. And they also force all the project funded by the government, for example, need to publish their data set if they get the funding from the government for that kind of science project. So, and also require those others to sign the data set with that kind of ID, because sometimes the data set is not, as the article, easy to do the unified ID citation. So people, they also create that kind of ID system to sign the scientific ID. So through all this systematic way, we want to have more and more data, experiment data to be shared or opened for the science activity. Okay, so I hope with that it will be better now. Yeah, even and we have the AI tools, but more important, actually, we should have the high quality experiment data from the scientific area.
Thank you very much. Well, this is all very important observations, because without data, we cannot really disrupt science, right? In order to create the data, we need to teach scientists to motivate them, change maybe incentives, so they can share the data. And that leads me, I think we are probably running out of time, so I'll ask the one last question, which will be a question and maybe a conclusion, and I ask each of you to maybe spend like a minute or two at most, right? So like very short answer. So the question is, I think it's kind of the heart of this topic of this conference, right? Open science for sustainable development goals. So this is global collaboration. But you know, the opening keynote showed us ranking of countries by all kinds of metrics. So you know, and I worked with Bosch. Bosch had the term for this called competition, right? So Bosch has a big ecosystem. Bosch supplies all the car manufacturers. They all compete with each other. They all use Bosch components. So they have this term competition, which means cooperation and competition. So in the AI, we clearly see this. So there is one kind of drive for sovereign AI. Every nation wants national data. It wants to grow its national institutions, national ecosystems, make sure it develops its own base. On the other hand, we have a global gathering here. We want all collaborate. Like SDGs cannot be solved by one nation pulling ahead, right? And so we see these examples happening around the world. So how do we reconcile the drive for national development okay, I guess it will be very quick, 1 minute. They promised to show me 5 minutes, so I take it as 5 minutes. So each has 1 minute. How do we reconcile the drive for national development, sovereign AI, with the need to global cooperation in science? 1 minute each.
Okay, so there are two aspects. One, base model. Let's collaborate with each other to build a few base models in the world, because it really requires energy, effort, and resources. Okay? And this is the Chinese word for that. 多极共生. I don't know how to translate into English at this moment. Anyway, one, 基模多极共生 for the base model. Second, I mean, for different areas, scenarios, 我的 AI 我做主. Okay? I think one of my colleagues said before, that said, for different scenarios, what I like, just let me do it for different companies, for different individuals. Let's have diversity. Okay? Thank you.
Thank you.
Thank you. So quickly, in 1 minute, I think open knowledge, open science, open source and open data are instrumental to share knowledge across in this AI era. I think the SDGs are a very good kind of compass to point us at the kind of the North Star or the direction of where things should be heading. And then finally on AI, I think AI for scientific discovery, or AI, what we're witnessing today, I think, is more of like an AI as a tool for scientific discovery to help scientists or engineers in their day-to-day quests. But I don't think AI is that position to actually achieve reasoning and actually make kind of physics theories, etc., come up with like observations. I think with the current status of LLMs, I don't think we're quite there for full scientific reasoning. So it's more of like an augmentation of the human capacity to do discoveries. And then echoing what Dr. Zhu mentioned is that we need more collaboration, more inclusiveness, and having everybody to have a word at the table, including developing countries.
Thank you. Thank you very much. Sure.
Besides what Minghui mentioned about the foundation model, and also there are things, I think one more things need to collaborate is to build a data curation platform, because the data for the vertical segment is quite important. And to my understanding and my observation, I think there's very few open source data, because there's really about no AI-ready data there yet. And we need tools, we need platform to curate and build the data ready for the AI. As the more data we have, the bigger possibility we have to have high quality open data. Yeah.
Thank you very much. Yuhua?
Yeah, I think no matter the science or AI today, the biggest issue is still to have the geopolitical things, create a war, and so for us, we need to try to find out a way to lower the barrier for global collaboration. And how to find a way for global collaboration, we should also collaboratively to find a way to do the collaboration.
All right. Well, thank you very much, panelists. Let's give them a round of applause. It was a great panel.
Thank you.